This video will show you linear functions and graphs. There are some worked examples and some questions. When you come to the questions, just pause the video and give them a go in your own book. When we look at relationships, we talk about dependent and independent variables. The independent variable is generally written on the x-axis down here, and the dependent variable is written on the y-axis here. So I've got x and y. An example of this could be a simple science example. That is, if you had a little beaker on top of a Bunsen burner, there was water in the beaker, you were measuring with a thermometer. Along the x-axis, we might write time. So as time is going on, the temperature is increasing. And it's increasing at a constant rate. It's just going up straight. It's not going like this. It's not accelerating. It's not slowing down. It's going up at a straight rate. On the other hand, if you had a beaker with some ice in it, and again, this was temperature on this axis and time on this axis, the temperature would be decreasing as we go on. So we talk about the independent variable is over here on the x-axis, dependent variable is on the y-axis. When we're drawing straight line graphs, we might be given an equation that looks like this. This is called slope-intercept form. Slope-intercept. So the reason it's called slope-intercept is we've got over here, this is the dependent variable, x is the independent variable, but the other two parts are this one here, which is the slope, and this one here, which is the y-intercept. So that's why it's called the slope-intercept form. We call these linear relationships because when we graph them, like down here, we actually make a nice straight line. So it makes a straight line graph, and linear comes from the base, from the word line. So as an example, if we're having a look at this graph just here, now this isn't any specific example, we've got the independent variable here, the dependent variable just here, and we've got them increasing the independent variable one at a time, and the dependent variable seems to be going up by 2. So we can turn this relationship, starting off, the 1 here means that when x is 0, y is 1. And then this section just here, that's the slope. That means that every time the x goes up by 1, the y needs to go up by 2. So x goes up to 1, and y goes up by 2. So 1 plus 2 makes 3. And then we get to x is 2, we add 2 on again. So we get 3 plus 2 makes 5. And you can see this is graphed just here on this linear graph just here, going up by 2 each time.
Okay, we'll go through a quick example of plotting from after you formed a table. So the first thing you need to do is actually draw your table out. So we've got sort of up here, x and y. And it's said in the question, our x values we want are 1, 2, 3, 4, and 0. So 0, 1, 2, 3, 4. All right, our formula is y equals 1 plus 2 times, remember it's next to it, it's 2 times whatever x is. So for our table, we have to think about firstly, when x equals 0, y equals 1 plus 2 times 0. So that's just going to be y equals 1. So I'll put that there. When x equals 1, y is 1 plus 2 times 1. 2 times 1 is 2, y is going to be 3. All right, so that's 3 here. And now I can speed it up a little bit. I know it increases by 2 each time, so that's going to be 5, 7, and 9. All right, next and very, very important step. This is something that almost all students get wrong at some point. We need to assign or label our axes. This one is x and this one is y. If you don't remember which is which, the way I remember, do my y with a really long, stupid tail. And that looks a bit like the y-axis itself. So I'm going to label the x-axis, that's 1, 2, 3, and 4. Now I'm going to do this next bit wrong first off, just to make it clear to you. This one here is 0, by the way. Well, my x values are 0, 1, 2, 3, and 4. And my y values are 1, 3, 5, 7, and 9. So I'm just going to go ahead and say 1, 3, 5, 7, and 9. The problem with this is that you don't just put every single one of these values on the axis. That's not how you do axes, not how you label them. What you have to do is do equal spacing starting from 0. So this one is 1, 2, 3, 4. We've got 0, 1, and 3. If I put 1 here and 3 here, the space in that first section is 1. The space in the second section is 2. You can't have different spacing between different points. So I'll just scrub those. This should start at, be appropriate to go every 2, 2, 4, 6, 8, 10. Now I can put my points on. When x is 0, y is 1, so that's going to be just here. When x is 1, y is 3, just here. When x is 2, y is 5. When x is 3, y is 7. And when x is 4, y is 9. What you might have noticed is that you don't even have to do every single one of those points. You could just next rule a line. I'll see if I've got something that works. Ruler here. Yes. That's not a brilliant line, but here could actually have just done a line straight up like that. The moment you've got 2 points, you can work out where your straight line is. Okay, it's done.